panelists on the floor for today's session, Security Open Sourced. So Mr. Lokesh Balu, Security Consultant there. So please come on stage. Mr. Upendra Pandikar, Executive VP and CISO, TIAA. Mr. Venkata Mela, ED Information Security Lead for GCC India's Philippines, JP Morgan Chase. Ms. Saloni Verma, Senior Engineering Manager, Target. And Mr. Ajit Menon, Chief Information Security Officer, TCS. Over to you, sir. Thank
you. Excuse me, ma'am. Excuse me. Me? Good.
A warm welcome to all taking time off. Today, we will talk about the IT industry is always been focusing on proprietary software. Open source, in my view, were not completely right. Came in as an alternate to from a licensing cost standpoint, that is how people started looking at it. The appreciation of open source as mainstream has possibly still not come. The approach that even organizations have taken to open source has in some way helped because you are able to customize things to a great extent, you are able to set. But then when we get on to the journey, the questions are far too many about the risks related to open source, how do we get support. So not just about the software, but also about the life cycle related to software, the upgrades, and so on. So the panel here is possibly going to help us understand how we could try and manage this up. And we will try to keep things that. No technology is perfect, open source is not perfect. And the whole intent today is to see which way the panelists with their experience have tried to do it differently to use open source together. So let me start with the perception itself. We all know that open source is not considered safe. That's the mentality. Now, it could be true in the larger industry context. It could also be true with security professionals, medium users. People tend not to believe that open source is something that can be relied upon. So, my question here to is how do we address this mindset? The cultural shift from where we are to where we want to. What are your views? How do you find the perception maximization?
Thank you for asking this question. I think it's a really good question. But before that, I would like to thank DSCI for providing this opportunity. Really honored to be here. So coming back to the question, I would like to open something with code. Open source is more around collaborating, not about competing. And when we talk about collaboration, it basically fuels innovation, right? And that is what open source is about. So jumping back to the question, which says that the mentality is fixated that proprietary software are more safer and secure. I think there are certain items that security professionals can emphasize on while talking about open source being also safe equally. The first thing is understanding the nuances that open source brings up and knowing that vulnerability is not equal to openness. The first thing that you need to understand is that there are many live examples currently in the industry that are existing. For example, Linux OS, which is a very good example of successful open source and which basically proves that it's robust and it's efficient and it's running pretty nicely in the industry out there with every pen tester at least using it. Even pen testing from the past have some of the other examples is Shell Shock when this vulnerability fell into place, which was a flash vulnerability. It got fixed pretty quickly, and that was because of the open forums and the discussions that community participates in the open source forum. So there are a lot of discussion forums where people can actually go and contribute, which is the main purpose of open source software. So those are the two major examples that I would like to portray that that prove that okay, this is also really functional. For more insights, I would like to pass it.
Thanks. So, building on top of what you mentioned, we have seen Linux and we have seen Apache as open source foundation is one of the biggest success. Even now, the era started after 2020 more on shared sources. So, how we can come together and then on the collaboration part actually, how we can build solutions that will help everyone. So, the way I look at it, coming back to perceptions, right? So, one of the key things, the perceptions is obviously always the same. How can we solve that problem? How much the data? So when you're supporting open source, what is the substantial data? So a couple of data points right now, 2026, $67 billion is actually for the open source. That is going to be the market. And 70% of the tech developers prefer open source. It is less in financial sector, around 27%, but on average, overall 35% definitely prefers open source. And maybe larger organization can ask this question around how much of their code they own. Hardly 20-30% you own your code. Rest all is basically coming from either shared sources or open sources. So there are a lot of transition that we need to get into. And three major factors, either it is a proprietary or open source, that we need to always look at is security, your licensing, and what is the quality of the software. So if you look at all these three, some research in the past, of course, it's a decade-old research, that defect density in proprietary software is more than open source, 0.72 versus 0.5. Okay, and of course, proprietary software is always behind a lot of shielding that you have in your organization. How strong is your other layers of protection depends on that. Once you get to know, like let's say you put a proprietary software in the open market, then you will actually see the comparison. You will not be able to actually, it's not an apples to apples comparison in general if you want to try comparing proprietary to open source. So it's, I think we need to look at all these things, how security is, how are we going to manage the licensing and other challenges that we will get into, and what is the quality that this open source brings together. So looking at all these things, I think we can definitely make a decision on what is the right way of doing this.
Thank you, Vicar. I think you made a good point in Saloni also. And since you spoke about security, if we were to look at kind of risks that we typically have been seeing, especially since the pandemic has started, more on the supply chain, starting with the solar winds as the big one. Okay. So, given that supply chain is a major attack vector, how concerned should companies be on open source? And what is your recommendation to secure this code? How do we secure the code that we are actually taking from third-party libraries or from any other community, building it into your code, or whatever is available on the internet, which your teams or developers may be actually using? How do we go about securing it? So maybe I put this question to both Mukesh and Pawan.
Good evening, everybody. So, I think our panel set the right context in terms of what open source means always, right? Before we address the security risk part, I want to start a little bit of recent numbers, right? Like when Kesh called out a few numbers, right? One of the major source of vulnerability tracking is the National Vulnerability Database. As of 2 days ago, it says that we have close to 30,000 CVEs issued, all in all, right? Which is the drastically highest number which we have never seen in the past. This is the highest ever, and this happened even before the close of the year. Of course, some of them could be 2020 to tag, but most of them were attributed to driving closure in 2023. So now, even if you take a rough estimate of 1/4, right, easily 25% of them, close to 7,000 CVEs or 6,000 CVEs in the open source packages. Now that's really, really massive. So now everybody gets fatigued when they look at the numbers and then they do not have the ability to chase it down. So now how do you really take a sense of it? Of course, you have a lot of other risk assessment methodologies, right? Whether people will use CDSs or they may use other risk methods to really determine the priority of the patching. But the biggest challenge comes in open source is you don't have any control on who is contributing, whether it will be managed or whether it won't be managed, when they will abandon it, so on and so forth. Now, this is the landscape. Now, when it comes to the other aspects of risk, we also do not know who is really working on those packages from beginning, till its end, and we cannot really trust it and directly use it. And when it comes to contributions also, we cannot really make sense out of who is actually contributing to it, what are their intentions, whether there are any telemetries embedded inside that, and etc. For example, we recently saw vulnerabilities related to NPM or dependency confusion, which basically talks about you have a package name. There is also a similar package name, but that's a vulnerable one, right? But our software tools may or may not be able to pick it. But of course, there are reasoned ones which are able to pick it up. So what I'm trying to say is we have a classic problem, but it gets complicated compared to the proprietary software. So all the best practices that we do for proprietary software, whether it is static analysis or code scanning or vulnerability scanning, will have to be repeated, but in a different scale. For example, in case of open source, the unique nature is we have plenty of dependencies. Some are direct dependencies, some are transient dependencies. When we say dependencies, one package will be referring to the other, and etc. etc. It could be cyclic. So now we may be finding one of the cycles could be good, but beyond a certain depth of the cycle, we may not have any traceability. So what we do? The other problem is traceability plus provability. So when you have a proprietary software, you can go and perform relative assurance activities, right? But can we do the same thing on open source? The third part I'm really important is also on the licensing. So some are GPG licenses, some are MIT licenses. So some licenses require you to contribute back to the open source if you're consuming it. So now, compared to this additional software or the proprietary software, you have these new layers coming in. Now, the additional complexity that comes with this layer is the supply chain, right? Now, supply chain, we talk mostly in the proprietary context, there are risks to it because we don't know who is checking in, what type of integrities that happen inside the code. When open source further complicates, right? We don't have any traces of these evidences so that we have provability of the software. So all these things means that you have a question on verifiability and assurance of the entire package. And the other way to look at things is when you have a proprietary software, you have full control on building, sourcing, and as well as packaging. So you have a visibility into the lifecycle. Whereas in the open source, we don't sometimes look into the source directly. In the interest of really delivering something quickly, we go and pick up a package which may or may not have an entire manifesto of security components embedded into that. So we should really look very hardly on the practice of not picking the packages themselves, but looking at the components that make up the package, so that we have little more control of the granularity. I think these are some of the pockets that contribute to the risk. And I'm not talking about the entire software development risk, I'm just focusing on the open source aspects uniquely, so we get some discussion.
And I totally agree with what you said about the looking at those components that are embedded within your software. So there are, when you talk about risk, right, there is one thing that pops up in my head which is called continuous monitoring. So how would you identify those risks? Is when you start to continuously monitor those using automated tools, or you start to identify those risks every time they are out of a certain patching version. So for example, if you have a component which is embedded within another component that could be vulnerable, you can't, it's very difficult to identify those kind of components manually, and that is when the automated tools, like there are a lot of tools also come into the picture. So I would like to.
So maybe continuing on this occasion, you and but there is a concept of reproducible builds. Right? A lot of people take that as theory and say that in practice trying to do that is not very easy. What is your view? It is surely a good kind of control against a set of attacks. How do you see that as a measure which organizations can build?
Sure. I think a little bit of context on the reproducible builds, right? So basically, builds are immutable is the overall concept. How we can make sure these builds can be reproduced as is, irrespective of the date, time, environment. So, of course, it's going to definitely help in some aspects of security, because one of the major issues that we have seen in the earlier Linux code and Unix code is basically this entire transmission issues. When basically your files are getting manipulated in the transition. So this is one area when your source code is actually getting downloaded or basically you are sharing it with a lot of others for this open source shared development community, there is always a chance that your source code is actually tampered. And this is one aspect that will help you to make sure that's not happening. Okay, be it the checksums and other processes that you have. But another challenge is that it's not always the code. How about the config that you feed in? How about the environment drift that you actually have in your environments? And also, the classic example is our log4j. No code change, no config change, nothing, but still have you learn. Okay. But how are we handling all these things is something. And the reproducible builds as a concept is now evolving, but I think this has been there for quite some time, almost like 2000, year 2000 is when this entire thing started. And we used to have a concept of derived objects actually. And a lot of software configuration management tools like IBM ClearCase and other stuff, they have this embedded as part of their production. And it's not only helping from a security perspective, but scaling up your builds and how fast your builds can be reproduced. And how you can actually leverage the build cache from one region to another region, one location to another location. This entire concept has been evolving. But the right usage of these concepts will help you in a lot of ways, security, scalability, stability, as well as how fast you will be able to do this time to market.
Yeah, I think good points covered by Venkat. So I'll also do one thing. I'll take a step back to really make everybody on the same page as what reproducible builds are. Right? As you know, this is pretty old. Think of a scenario where all of us are given ingredients to make a soup. It could be vegetable, pepper, salt, ingredients, other ingredients you may need. So imagine this entire room of people are given those ingredients. Can we all make the same soup as an outcome, the same quality of taste? Probably not, right? Of course, some of us could be chefs here, or some of us could be passionate in cooking. But even though we cannot really produce the same quality of soup, given the same ingredients, same environment, same utensils, same setup. So this is exactly the challenge, right? So now, why we are talking about reproducible builds? We need traceability. We need provability. So the traditional approach is, okay, I'm doing code signing. Okay. So what does code signing give you? Code signing gives you an ability to verify the integrity of the software, right? But it will verify the integrity only at the time of signing, and it does not have any intelligence about what actually getting signed, right? Imagine if there are any modifications during the signing process, it will sign even those malicious components. Good example is the SolarWinds. We all know that, right? So what exactly happened in SolarWinds is this scenario. They went and compromised the build environment with a DLL injection vulnerability. Because of the DLL injection vulnerability, there is an Orion platform from SolarWinds that got infected and that got shipped to multiple customers. So instead of really causing a damage to thousands of customers using SolarWinds, they just did that infection on the build environment of the SolarWinds. So now everybody thought, yeah, there is code signing, it will help protect them. But even before that code signing could take effect, the build environment was infected with the malicious DLL. So which means that the malicious DLL itself got signed from the Orion platform and got shipped throughout all the customers, and all the customers got infected, and the threat actor was able to extract or exfiltrate data based on this view. This is a great example of a supply chain risk and supply chain attack on an open source or a commercial software. Doesn't matter. But the focus is on how certain controls like code signing is giving it a sense of wrong integrity verification or wrong provability of verification. So that's the one. Another good example is a company called CodeCurve. They are proprietary an open source software to manage the codes, right? In their case, they were using a Docker image to really perform code signing activities, right? The Docker image is a bash script, and that bash script has passwords in plain text, right? This is also another scenario where we are taking not so good attention on various metadata that happens throughout the build environment. So how do we really then use reproducible builds? So when you have same inputs, it should produce the same outputs. Any system that has the oversight on the entire life cycle, build environment, build tools, build scripts, source code, everything has to be reproducible and it needs to be verifiable from scratch. That means, given the same setup, anybody across the system would be able to prove it because they're going to build it from the source. That's why in my first example I gave, let's not worry about downloading the open source packages. We have to download the source and build it from scratch. And if you have a reproducible build kind of a setup, it becomes extremely easy for us to prove the software and also trace it back to its original components. So that's the advantage of reproducible builds. Even though this is a pretty old concept, I think it is gaining prominence recent past because of the various supply chain angle to the current vulnerabilities that we are seeing.
I think you have made very interesting points. When you talk about what is getting downloaded, what is getting included into your build, etc. I think it all boils down to inventory. Okay. And we all know that the SBOM, software bill of material, is a very key component. In your experience, is that still something which people would do more as a tick in the box, or is it really followed in spirit to an extent that it is used well to track the source and also so only you can or anyone else will be
Sure. So, taking a step back, I'd like to explain what SBOM is because when I heard this, I wasn't too much aware because I think there are different terminologies that are used for this similar thing that is called SBOM. It's software bill of materials, like you mentioned. It's more like a list of pre-made softwares and versions and everything related to that software that a security professional can refer to just so that they stay in sync and they follow the best practices possible in the whole security environment. So that's SCOM in my opinion, and I think it is followed in a lot of organizations, and organizations also refer to SCOM in security incident responses, for example. If you see the threats that come in and you see the threat landscape, right? There are a lot of pre-made vulnerability databases that security incident team can refer to, which basically tells you what path of pre-vulnerability which already exists, for example, log4 that you mentioned previously, can take, and that path basically guides you on what else can be the breaker of that particular system. And just so that you can refer it, there is also an option of report generation in SCOM where it lets you generate a report and follows the exact same path that an attacker can basically go and break the system in. So that's a guideline that a person can actually follow. And other than this, I can remember that using SPOM, there are also other ways that you can identify those risks where whenever you scan a component, there is a prompt patches that it suggests you that you can probably like put into the picture so that it guides you on what is the latest patch of, for example, log4j or Apache. Similarly, there's one more example on licensing. It does give you the latest license that needs to be patched for a particular component that you're using in your software development lifecycle. So that's the use of SCOM and
Yeah, just want to add a couple of additional things, right? So it's all about what's the traceability to the latest point, what's the traceability back on how your software is built, based on which components, what version of the component, everything. Traditionally, we used to have a manifest file with all these details, what version of GDK you are using, all these things. Then with Maven and other tools, that it became really easy with polytopic model, form files and everything. Now it's SBOM, and SBOM is basically becoming very famous after the executive order in 2021 by Joe Biden. And also thanks to Log4j, we learned a lot from that. So it's becoming so famous now, and it's now a regulatory kind of a requirement in every organization. So to your point about is it a tick box or is it a strategic thing? In my case, it's both. For now, we need to be complete. Okay, so it is a tick box for now. But in the long term, we need to have a strategic solution. So how we can make sure all the software is scanned in first place. Like obviously, how you are adopting all these open source softwares and like properly scanned and properly managed within your environment. At the same time, how you are contributing back to the development using the open source. And how you are further sharing this particular thing, what you develop into So all these three areas, you definitely need to have these practices, and also you need to have some proper standards, guidelines, and controls. I think the industry still need to make sure that especially the
So I think there are three things. One is transparency, auditability, and provenance, right? So now with SPOM, as our other panelists called out, it's becoming more prominent because of various needs from government agencies and systems. But actually, if we look from the practical standpoint, how do we even do it when we don't have access to the entire dependency thing, right? So that what brought brings us to the question of using automated tools, right? At the very instance of we trying to source a package from any open source community, we need to really have automated way of doing it. So like think of this classic case of inventory management. In our data centers, we have storage, compute, network, and variety of other equipment. We do manual inventory, sometimes we do semi-automated inventory. Similarly, when we talk about open source, from the time it is brought into a pipeline, we need to have a robust inventory management. So there are dependency management tools, both open source and commercial, that are available, which can be related. So that's step zero or step one. Second thing is really looking at from a tagging perspective. So if you look at again the classic inventory management principles, we classify assets based on whether they are internet facing, they are located in a particular PCI zone or any other particular compliance stage, etc. Similar to that approach, you should be able to catalog and tag your open sources. Mainly they are used for platform development, they are used for front-end development, they are used for web server use cases, etc. And when you do all these tagging and inventory management and also use semi or fully automated dependency management tools, open source tools, commercial or freeware tools, what you will get is you will get a reasonably good baseline to start with. That way, we will really be able to unlock the resistance. As Venkat called out, Ajit called out, we have a challenge. Is it still a ritual or people are going to be doing it? So that's still a big question. Unless we make the life easy and unless we start the baseline work, it's not going to, the ball is not starting. So I think these are small merging points which we can start, and there is no big effort required in these cases. But really having the adoption increase across is going to be on the longer run. Sometimes there is a regulatory push, sometimes there is government or other push, but we have to start doing it. There are enough opportunities to start take that.
I think very good point. Both of you. So while I do agree that I think he made a very fair point. Practically, it is sort of in the box, and hopefully over time people will understand the seriousness and do it in spirit, and that's the better part. Now this is just one component of looking at open source, but CISOs are generally expected to have inventory of everything. Okay. So just extending this, not wanting to spend too much time, how practical is this approach, or can the same inform component, the way we're doing it today, can it actually scale up and support the organization's inventory management? What are yeah, so two aspects, right? So SBOM is more on what are the components that we are using within your application versus your entire CMD, okay, where the CISO needs to be completely aware of. Okay. I think yes, it is practically possible, but how much effort and budget that you have in your organization to have a complete view, okay, is the question. It's how much investment you want to make in that space. You really want to know every little corner of your organization, every application, every layer of your application, every database that it uses, every API call with the public cloud. So, how many of us really know what are the public cloud services that every application uses, and what are we getting charged for? So, a lot of these things are basically they have individual systems. Of course, every organization will be having individual distributed systems to measure these things. But can we all have a single pane for a CISO that can get a full view of what's happening? Okay. Yes, it is practically possible, and I think in my job, probably one of the things that I try to take that view and to make sure that we get that view. Yeah, and also how much technology investment you are doing, how much engineering to get this. So it's a very important. Like again, I'm going back to the
when Log4j happened, there are organizations that has taken almost a year or two to fix this issue everywhere. Imagine if you have a complete understanding of your entire ecosystem, all your applications, all your dependencies and transfer dependencies based on it. Then it would have been a just quick thing, and then Resbomb is definitely going to help us there. If something like this happened again, so our jobs and lives would be a little better than what happened in the past.
Since we have time, we'll take more questions and then I'll open it to the floor. So, what are you, I think you spoke well about us also having to contribute back. What do we do? And I think that's really the strength of open source. That it is not just about a particular developer or a set of developers coming together. It is the community at large coming together on a particular project, trying to do the best. People improving it, and it's not just that it's done at one point in time. Over time, people keep putting at the core and improving it, trying to secure it further, improving it from a performance standpoint, etc. What all ways can the community contribute to this? Because today, I know that there is, if I were to take difference between people using it versus contributing, I think the contributors are present. How can we actually change the dynamic? How can we go back to a model where people feel that they can contribute back to society and overall open source can be much better?
So it's always a thing, what is in it for me? Okay, when I contribute, right? So I think we need to change this entire open sourcing operating model more than a charity to something which is meaningful, where individuals are proud that they have done something. Okay. And also they get something back. Of course, it cannot be only the monetary thing, but there are multiple dimensions that I look at in this aspect, right? So what individuals, like especially the core open source developers, can do. So can they make sure they are following the proper open source standards and they're making sure whatever the code they're contributing is the quality. There are a lot of third-party platforms, right, where you contribute some code to them and they actually evaluate your code, they rate your code and everything. There are a lot of such things that they can practice all these things. At the same time, what organizations are doing, are they encouraging open source development? Do they have the right controls and guidelines? And also, are they encouraging their employees to contribute back to open source projects? A lot of, especially in the financial industry, there will be a lot of restrictions. So, how open we are as an organization to contribute? And also, as an organization, are you ready to really fund some of these open source projects, which is going to help you to look at that industry? Like one of the best examples, like Facebook React.js. Okay. So the kind of push Facebook has on React.js, it has now, I think, the 17th version or 16th version is going on. Whereas other similar UI open sources actually hardly third or fourth version at the same time. Because it has a backup and there's a lot of leverage of that open source. It has definitely traveled a lot versus other comparative open sources. And another thing is what the basically the community like DSCI and other stuff can do. How can we bring this to a common platform and share with each other? Okay? So as I mentioned earlier, it's not open source anymore, it's shared source. So how can we transition from open source to shared source? And how we can get benefits out of it also. Okay, so of course there are a lot of examples in the industry, like MongoDB is one of the best examples of shared source. And also you can help co-collaborate basically with larger organizations. Let's say you have a good open source community and then larger organization can help you build, solidify the entire source code and everything. And also sometimes a lot of open sources, they came up with this new model. Okay, basic features you take it for free. But you need some specific customization or additional features, you need to pay this. And how this funding will be managed, and how this entire crowdsourcing and crowdfunding will be managed. Who are going to get the credit of this source coding, or also which organization is going to take the overall ownership of this? It's not just about the code giving it for free, but if something goes wrong, who will be owning that entire part to fix it? A lot of companies have a model of, okay, you take it for free, the entire software, but if you need a support, okay, you need to pay this much. So these are the models that will definitely help, okay, in general, to basically take this forward.
In that, just one point about when you talk about open source, it is not just national level, right? So we are trying to get practices in multiple countries across the globe. So I would also urge all the delegates to look at the international efforts. One such effort is the OpenSSL, the Open Secure Software Foundation. So after the Heartbeat ones that suddenly called out and shell shock vulnerability, they have started pulling money from big corporates. I think Google and few others were part of this. So what they do is they do an inventory of widely used packages. That it could be Libra SSL, OpenSSL, or any other internal modules, and then give funding to dedicated core developers who are responsible for maintaining it, especially focusing on prioritizing the security defects coming out. So why? Because we all wanted to maybe try to use that, but we are not really contributing back. So the big corporates, because they are already using a good amount of those packages in their product development and software development applications running behind the data centers, they wanted to pull it and leave money. I think many big corporates are there and they have fantastic efforts, initiatives, some of which if time permits will cover. I would urge all of you to check that OpenSSL website where you will find a lot of ideas on how to contribute back and what are the initiatives running where people are collectively joining hands in improving the overall quality of security of the open source rather than other aspects.
So, maybe I'll take a last question and then open it up. I think from whatever all three of you are saying, there obviously is risk, whether you use proprietary or open source, there is a risk, and it is more about how you go about handling it in a proper manner. So, what is your recommendation from a framework standpoint? What are the risks, and hence, what should the framework in your organization should actually adopt to make sure that the usage is right, and we don't end up going back to the initial position, right? And having these problems because of the open source, right? So, what is your recommendation? What should be the journey for people who want to adopt it? And what should be the framework that we should?
I think in terms of risk, we have covered a good amount of risk. So let's not rely only on integrity verification or let's not assume trust and download them. Look for provability, look for traceability. Right? These are the aspects of risk. But I think more importantly, we should talk about what are the solutions we follow. Right? There are multiple things. At least we can break it down into two categories. One is a set of frameworks so that there can be organizations who can institutionalize this. So the first among them is setting up an open source program office. So today we may have a program for IoT or program for mobile security or maybe dedicated for AI also in these days. But it's high time that we set up within a software security division or the security organization. We have a small team who looks at open source program office because there is a policy angle, there is a legal and licensing angle that some of our colleagues talked about. There is also a compliance angle. Then comes the risk of the security vulnerabilities and stuff. So we need a program office to really run this as a program and institutionalize this. So as a side effect of that, we should also have a policy. Now once we say policy, then there comes the question, what's the industry doing about it? So I think again I would fall back on OpenSSL, right? Because OpenSSL has a couple of useful frameworks to start with. The first thing is when you pick up open source, the first question comes is, can I trust it? If I can't trust it, what are the parameters to check? So there are 20 different heuristics. For example, when was the last commit done? Where are the geographies in which the developers are contributing to the package? How frequently they are making updates? Where are any CVs issued on the package? And what is the response time on the CV? These are some of the very minor ones, but there are 28 different heuristics based on which they have created a program called Open Source Insights. So before you pick up an open source package or source for your product development or software development, try to look into that database and see if that helps. There is one framework. The other one is Google has released SLSA, software licensing framework, right? So they have created 4 levels of maturity. Again, it is useful from an institutional standpoint because you can have, say, you are doing a small pilot project. You don't even really spend a full cycle time. So you can attach the level 1 related requirements. Say if you are doing level 2, level 3 to increase the level of maturity and governance and assurance stack. So that is another good way to look up. And then if you really wanted to see signatures, there is another project called Six Store in OpenSSL, which will look at the entire key management and signatures tied to each stage of the build process. Traditionally, what we do is we sign the code and we forget, but we need to also sign build artifacts so that we give an ecosystem-wide protection with open source. Because looking at the examples from SolarWind and others, we can see that it is not just the software vulnerability, but it is the vulnerabilities present in the ecosystem in which the software is created, which is actually causing the problem. So which means that we need to have a holistic treatment. The sixth store is a project that talks about how do you store and manage your keys of various artifacts, not just the source code. And then there are a couple more projects that talks about how do you really handle the visualization of the entire vulnerabilities across the different entities. We need probably a graphical view of the vulnerabilities from the main package to the branches and etc. Right? And I think while we look open source in a special attention, I would also want to step back and see open source as a part of any software development. In that context, NIST has a framework called SSDF, Secure Software Development Framework, which has been in practice for the last couple of years, which is a fantastic approach. Even though it is generic to any software, proprietary or commercial off the shelf, but it equally applies to open source if we are contributing back into the community rather than consuming it from the community. The first few things I suggested, if you are a consumer, the last is this SSDF would be good if you are contributing back. I think I would emphasize on this.
So the few of the frameworks that I have used personally are, one of them is SCA, which is Software Composition Analysis, which basically tells you that what are the components you're using in your code, and it's scanning on a regular basis, providing you highest critical the mediums around that component. Another one that I can think of, which is very famous, is GitHub Labs, which gives you also a solution of what you should be doing to improvise your code in components that you're using in that specific code. A lot of us talked about CDE, so that reminds me of CDSS being another framework that everyone, I think probably everyone here uses, that provides you a number of how critical a component's vulnerability is. For example, Log4 they got 10 score in CDSS, which is the highest, and it's very impactful number that way. So those are the top three in my mind when I think about that.
Yeah, just want to add a couple of points. Like, in just short notice, I want to just, I think we need to change our mindset from compliance to security. I think we have been focusing a lot on compliance, making sure all the controls are met with, and we need to look at how frequently our scans are done, how frequently we are able to follow the vulnerabilities, because that actors, the best they can actually handle anything in 50 days. Right? But are we really scanning that frequently? All our source codes and everything. And also, in general, you probably scan only one branch, this branch, or maybe only your production environments. Are you scanning every branch? Are you scanning everything? So these are all the other challenges. I think from a risk perspective, there are a lot of areas that we can focus. Be it the security risk or standard technology risk, and also this current geopolitical situations, whatever is happening. All like funded the resources are funded from resources actually trying to take up a lot of risk. So those are different challenges. But how are we going to tackle it? I think a couple of things I can use around secure from start. So I think we all should have that in mind. Whenever you are introducing any new component in your environment, you need to first secure it and also you should have a frequent check of course, your vulnerability scanning. So how early you are able to detect and how fast you are able to fix it also. I think one of the things is we scan a lot, but sometimes a lot of organizations have a luxury of fixing this particular issue for 365 days, which is not going to help you. Sort of. Sometimes your vulnerabilities, it may not be a high end item right now, or maybe a high priority item right now, but it may become a high priority if you are actually sleeping on it and are not able to focus on it. So these are the things that how fast you're like how early you're able to detect, how fast you're able to fix, and how frequently you're able to make sure you're scanning all these environments. Okay? And this entire thing is actually a regular practice that we shall, of course, we need to use a lot of tools, automation, and engineering practices. And one of the key things that I always focus on is actually the developer discipline or developer practices. So there are a lot of tools in the industry today which will tell you when you are coding itself, this particular code will actually have vulnerability of this version in this particular design. But as a developer, I need to react. I need to accept that recommended fix or maybe. I'm always worried about my features. Okay, so developers usually focus on, okay, I need to just push this feature. But am I really focusing on all these additional things? Okay, and do we have proper controls? And of course, I understand from developer perspective, we should not be putting a lot of load on them. How we are going to simplify all these aspects to the development community is also another thing problem we have.
So just want to emphasize, when we talk about open source, we need to also focus on the incident response, right? I'm not talking about the CSET incident response or computer security incident response for a corporate records, but more from a product security incident response. Most of the organizations have this function, but they respond on the vulnerabilities originating from the proprietary code. But if your product is a combination of proprietary code plus open source code, it becomes all the more important how you catalog, do triage, and then work with the community until you go back to your own customer who is facing this problem, because our product carries a piece of open source. So all the product security incident response function in multiple corporate organizations will also give special attention to open source response. Right? That way we will have both proactive, that is your secure software development and build environment and all the good things that we talked about, plus the reactive components of how do you respond to it when things really go wrong beyond your heads. Because we cannot really expect a log4j or another thing not to happen, right? It may be on another package. When that happens, we cannot really wait. There should be a response preparedness from a product security incident response angle, which is paramount in everything.
Very good wealth of knowledge. Whatever we typically talk about in terms of contributing to collective wealth, in your collective wealth, surely help the audience here. So we are just about closing the session. If there are any questions from the audience, no, I think you all were quite informative. I started the session by talking about the fact that nothing is perfect. Everything has a problem. I will conclude by saying, yes, there is a problem, but be sure that in the case of open source, good guys are fighting. That's the confidence we have, and that's why we will start shifting to it. Thank you. Thank you so much. It's really great. Thank you.
So I request the support to hand over the